Alright, Chapter 12, Electronic Simulation and Layout Software. In this chapter, we introduce the analog circuit, simulation software, and circuit layout software. Introduction software would design all circuits with the basic electronic subcircuit with the building blocks and construct the large circuit of the use of the design of the circuits, calculating the state of the behavior of the response to the small AC sim wave signal deviation with the quiescent state. While those methods useful for the coming up with the overall design of the circuit is slow and limited methods for the predicting ideal theoretical behavior circuits under all experimental conditions. Computer-based analog circuit simulators. Computer software circuit simulators very good at calculating ideal theoretical behavior of Kirchhoff law. While circuit simulators will not help you come up with the insight with the creativity to design a good circuit, will use the helping to the elucidated to quickly benefit the disadvantage of one circuit to design it against another. Generally, you simulate with a circuit much more quickly than you can build, test on the breadboard, or add little practice of the core of the circuit simulator will also try with many variations circuit relatively quick. Industry standards along analog circuit simulation software, or the simulation program integrated circuit or emphasis or SPICE, which was originally developed by UC Berkeley during 1970, early 1980. The simulation program integrated circuit emphasis version 2G6 is the basis for many of the commercial computer software programs. The program provides a graphical user interface, but SPICE or WinSPICE simulation engine to perform all circuit calculations. The simulation program in the integrated circuit emphasis does not simulate electronic field circuits since they depend on explicitly the layout of the circuit. The result of SPICE can be trusted on up to the low megahertz range, should be treated with a sufficient higher frequency. In this course, you will use the commercial software 5SPICE free with the non-commercial use available at 5SPICE.com. B. Computers-based circuit layout edited. This electronic labs, you have a design layout with the bread circuits on the base of the fly with a professional setting of the layout with the circuit to determine the compactness, ease of the use, the debugging cost, longevity of the performance, especially high with the frequency number of the programs, just help you circuit layout. In fact, the industry of the most electronic engineers design abstract circuit with a circuit simulator, then they use the software package layout with the actual circuit with the printed circuit board, then the paper circuit layout design turned into an industry standard Gerber file, which is sent to the printed circuit board production company prototype with assembled, tested, engineered company with a PC board electronic components. Once it is tested, entire production usually is contracted out to a third party. In physics research lab, the production is done in the house. Generally, the use of the professional PCBs are relatively common and says generally resolve with a reproductive circuit with which is likely to work better with a higher frequency than one together with the wires and prototyping boards. In general, this will commercial software Eagle and CADSoft free non-commercial use available to CADSoft USA. 2. 5SPICE circuit simulation 2-step process. The first step, they must construct an actual circuit diagram, wires, electronic component, resistor, capacitors, inductors, diodes, integrated circuits, etc. Second step, you may input the circuit to see how it affects the circuit operation and outputs. Program's relatively easy to use. To start with the program, you get the blank schematic drawing canvas to import with the graphic user interface elements, the ones that will allow you the most. The main screen I'll show in figure 12.1 below. Simplest way to introduce 5-step is with an example of which must show the analyzed gain of -10 inverting amplifier and its op amplifier will shown in figure 12.2 below. A circuit diagram first to build with a circuit diagram in 12.2. We start with the central component, the LM741CN op amplifier. Insert the amplifier going into the op amp icon, selecting the op amp subcircuit element, which drag and drop onto the schematic canvas as shown in figure 12.3. Schematic canvas now has a single op over the middle of the figure 12.4 below the schematic and singly undefined op amplifier. We now identify with the op amplifier 5SPICE now have to simulate with the properly given the op amp with identify with the op amplifier, finding the op amplifier library. You look at the selected op amplifier subcircuit with the library right over the clicking on the amplifier component image, selecting edit parameter, menuing the list figure 12.4 below. Edit parameter selection calls up the subcircuit library which can search for the desired op amp shown in figure 12.6. In our case, the only op amp subcircuit is available, the LM741. And select this one, you can find the SPICE the model with a component that looking for the library, but you generally find the manufacturer's website if not must simulate the another component. And it shows 12.5 and 12.6. The op amplifier is now identified with the op amplifier 5SPICE will simulate it such. You must now construct the rest of the circuit, the resistor of the passive components, the icon menu with the lever, the drop technique with most of them, the schematic canvas, the vertical with the rotate, right clicking on the resistor component image and selecting rotate menu list. Alright, when you now rotate the mirror flip of the op angle of the component image, you do the same technique with the traditional orientation. Now, copy and paste the resistor to make second one and move it around the starting construction over their circuit diagram shown in figure 12.8 and below. When we convert the topmost of the 10 kilo ohm resistor to the 100 kilo ohm as for the level left, double-clicking the resistor component image, right-clicking on the tree of the edit parameter menu with the list of the 10 kilowatt, the value 100 kilowatt resistor parameter window is shown in figure 12.9 below. We only need to add wire with making sure the inverter amplifier was doing. Select the wire drawing icon and is shown in figure 12.10. We drove the wires inverting and amplifier. You with the mouse cursor, you can stop with the wire tray hitting the escape key. You're now ready to attach the ground positive negative supply voltage op amplifier power icon menu that is shown in figure 12.11 below with the drag drop the ground with the positive turn op amp with the positive negative supply voltage op amp also. We attach the 15 volt supply, negative 15 volt supply op amp also connect the op amp to the ground, then give it the following sequence at figure 12.12 below. Last addition circuit diagrams input output signals. We add a voltage signal source input inserts of 1 kilo load resistor output along with a voltage test point final circuit drawing is shown in figure 12.13. B. Circuit analysis. You need now to analyze the ideal theoretical performance of the inverted amplifier circuit. With the circuit, all circuit starts with the analyzed dialog, which can access the analyst menu shown in figure 12.14. Analyst dialog also performs the three principles type of the analyst of the circuit: the DC bias, AC, and the third transistor. Analyst type can be chosen. The analyst type of the analyst dialog is shown in figure 12.15 below. Now review the three types of analysis. DC bias analysis. The analyst determines the state of the quiescent operation circuit. The type of the analyst does not produce the plot. We apply with the inverted amplifier circuit. Clicking with the apply run button 5 spice. Calculate the DC voltage current sending the output of the DC bias tab. Main window is shown in figure 12.16 below. AC analysis. We find the analyst dialog. Set up the AC analysis shown in figure 12.17 below. The AC analysis consists of setting an AC signal input determined with the voltage signal through a circuit diagram, screening the frequency to determine the frequency response of the circuit output with the other test point. In the other cases, we scan the frequency input with 10 megahertz. AC analysis is done in frequency space. AC analysis generally output a Bode plot with a frequency scan. The plot can be tailored with a trick with an analysis graph table under the analysis dialog shown in figure 12.18. The AC analysis will choose the plot both the magnitude phase of the output AC signal. We run the AC analysis 5 spice calculate the behavior output over the frequency scan produced with the Bode plots with figure 12.19 below with the graph display AC1 tab with the 5 space main window. If necessary, computed value of the plots are saved with the file. They are also displayed for the report tab of the main 5-spice window. And 3 transistor analysis also done with the time domain spices numerically computed for the time and the evolution of the circuit voltage current function of the same time varying input. For our transistor analysis, we choose 10 kilohertz square wave with 0.1 volt DC offset with 0.1 volt peak to peak. We should have selected the analysis tab analyze dialog window shown in figure 12.20 below. Transit analysis set to compute the time evaluation of the time 0 state to the time 2/10,000ths of a second. Your transition analysis is most difficult, frequently one most adjust the parameters govern the numerical computation simulation work in figure 12.21 shows some of the basic changes of the numerical computation schema on one select the transit analysis to compute. If the transit analysis cannot be produced in solution, adjusting above selection of the parameters given the tolerance and the convergency criteria of the numerical computation must be followed. Figure 12.24 shows the project default tab, dialog analyst dialog window. Various parameters should be adjusted to obtain the transient numerical solution that can be taken so the adjustment will also affect the accuracy of analyst results. The result of transistor analyst plotted verse time on the graphic must set up with a similar manner shown in figure 12, 18, and 19. AC analysis output plotted in the transistor 1 tab maintaining 5 spice window as figure 24 below show our inverter amplifier applied with the input of the gain of -10 that does not show the distortion due to some of the internal resistor capacitor low pass filtering. If we make actual circuit lab, it should be not except better performance, which is shown in figure 12.23. In conclusion, we have shown the construction of the circuit diagram, 5 SPICE, dues, PS BIOS, AC, transit, and analog circuit. The introduction is not meant to be comprehensive. The reader is encouraged to read up further on how 5 SPICE from the help menu. 3. Eagle version 4.1.6R2 circuit layout software used the converting circuit diagram circuit layout, which can be sent to printed circuit board manufacturing automated production. As 5 SPICE, you must first make the circuit diagram Eagle so they can help produce the circuit layout. 2-step process you will go through by using example of the inverter amplifier previous section. Circuit design Eagle is similar to 5 SPICE. You open a blank schematic canvas with the drag and drop the components on the library. You can attach the components with the wires and add power. You must select the use of the menu item in the library menu of the Eagle schematic window. Open library access its components. We will be using Quantum Op library. Figure 12.24 below shows the Eagle schematic window. Important icons, menus highlighted. Once the schematic is complete, is converted in a board. Selecting a board command shown figure 12.25 below. B. Circuit layout. The printed circuit board produced by the make board button still requires a lot of work. The first step is to place the components and props appropriately on the board areas indicated in 12.26. After using the make board button, circuit components should be placed in appropriate locations on the board. An important factor to remember: the board has 2 sides. You can use the placing components, the routing wire trace to the next step of the route of all the wires. This does be done with a certain extent with the auto router feature, though one must still route some of the wires by hand. Generally, the wire routing shown in figure 12.27 below. You have the active layer, route yellow wires, wire manual router tools, auto router tool. Wire routing, generally bulk of the work type can take quite quick long time. Should remember the circuit 3-dimensional, that you can use holes and visas conducting hole content, connect components and wires after routing wire that the board has formed and shown figure 12.28 below. When making a board, we will work on the radio frequency. A good rule of thumb is how to have much metal around the grounded voltage, which is ground voltage. Large area metals are called ground planes, helping shield parts of the circuit from one another. Furthermore, one should try to make sure that the wires are transmission line ideal for the 50 radio frequency impedance. Each of the wire has ground on either side, above or below, depending on the orientation. 12.29 show the board after filing and all of the blank areas of ground planes. And then C. Gerber file. The Gerber file industry standard computer file contains all of the information necessary for the printed circuit board. Once a board is finished, then we make a Gerber file going to CAD and computer-aided manufacturer window for CAD and CAM button. The CAD aided manufacturer window selected device Gerber Auto, and include a file name and process job button. With a Gerber file, you can send a PCB manufacturer automated production. In conclusion, we've shown the constructed circuit board. The PCB is with the Eagle introduction. Comprehensive reader is encouraged to find further information on how to use Eagle from help menu. And then it shows the lab, and that was chapter 12, electronic circuit simulation layout software.